It's a DB scan. So now, can anybody tell me the full form of this DB scan? On what principle this DB scan based on? Hello, am I audible to all of you? Okay, fine. So this DB scan, the full form is a density based algorithm. So it's a density based spatial clustering of with noise application with noise. This is a DB scan. So it is a density based algorithm. Okay, so this K means that already that we have covered. This K means it's a partition based. This one is a partition based algorithm. Okay, partition based, or you can say it's a centroid based algorithm. And yesterday that we had covered one algorithm, unsupervised one, that is a hierarchical clustering. So hierarchical clustering, this DB scan, K means, okay, Gaussian mixture model, this all are the unsupervised machine learning algorithm. And this there is a difference between this K means and DB scan. Okay, so K means is not perfect clustering algorithm. That is K mean that we will see uh, in the last when we compare this DB scan and K means. So at that time, okay, so we will do the comparison in between this DB scan and K means. So here the K mean that we can say right now is a not perfect clustering algorithm, and there are some limitations of this K means, because we have covered this K means. So now we can discuss the limitation of this K means. Okay, so the first kind of limitation of K means, so first one is that we have to tell in advance number of cluster, how many number of cluster that we want. So this number of cluster we have to tell in advance prior. Okay, so this information we have to give prior to the algorithm, how many number of cluster that we want. Okay, so that is the first one. So number of cluster we have to tell in advance. Now the second one is, if we have the different size of cluster means, let's say this one is a um, different size of cluster. Let's say this one is a one cluster, okay, and this one, so sorry, one group of this data point, and this one is another class. Okay, so the K means that will make a cluster. Ideally, any clustering algorithm that should make one cluster and another cluster. Okay, but the K mean that will make a cluster like this one. Okay, the reason, because it has a tendency to make a spherical shape of cluster. So K means that has a tendency to make a spherical cluster, because it is based on the centroid, because this one is based on the centroid. Okay, so it will make always circle or spherical shape of cluster. Okay, so that is a problem in the k means. Now the third one, it is sensitive to outlier. This k means is sensitive to outlier. So what does it mean? So let's say this one is our data point. Okay, and this is the one cluster. Okay, fine. So if suppose outlier are present here in our data set, so the centroid that will shift towards to this outlier. Earlier the centroid was here. Okay, now just due to this outlier, this centroid that will shift towards to this outlier. So now the new centroid that may be here. Okay, so if centroid shift, then it will not perform well in the next stage. Means it's not a good sign. So that is a third drawback of this k-means clustering. Okay, so this one is a partition based or centroid based algorithm. So now come to this DB scan. So this DB scan is a density based algorithm. This one is a density based algorithm. Clear? So density based clustering technique. So let's say, for example, um, the intuition of this DB scan, we can understand. Uh, let's say there are some group of people are uh, in the garden. Let's say this one is a garden, let's say, and if we see uh, this garden from the top side, okay, means top view, then we see the cluster of children. Okay, see this one is a cluster of children, then DB scan that will make a one cluster. Okay, means group of children. So here are some group of person that who are doing the physical exercise. Okay, so this one another, that is bunch or group of person. Okay, male or female. Clear? Then the DB scan that will make this cluster like this one. Okay, so if point is, if one or two person are sitting on a bench, okay, then DBs can call them as a outlier. Then this one DB scan that will not make a cluster, so this one as a outlier. Okay, it is not the part of any cluster. So the basic principle of this DB scan is, this one is a density based clustering algorithm that divide our entire data set into dense cluster, okay, separated by the region sparse region. Okay, means that is a dense region. I should say here that is a dense region and separated by the sparse region. Okay, so like this one means this one is a dense region, this one is a dense region, and this one that is a sparse region. So here one or two person, if suppose sitting on the bench, then this DB scan that will not consider this as a one cluster. Okay, so now in this one only two clusters. So this data point that we will call as a outlier in the sense of DB scan. Okay, so these are the data point, but the DB scan that will call as a outlier. So now let's say this one, another example, this one is a data set. Okay, This one is again another bunch of data point. Okay, this one, let's say 3 data point. Then the DB scan that will make a one cluster, fine. This will make a one cluster, fine. Okay, this one is outlier. So DB scan that will not consider this 2 or 3 point. Okay, means 2.3.4 point that we will see. Okay, means how many minimum number of the data point should be considered to make a cluster. Okay, so this is a kind of hyper parameter, so that we will see in the next one. Okay, so this is the kind of the definition or intuition of this DB scan. So now question is, how do we can define the noise? So noise, actually the point is, let's say this point that I will explain. Okay, so let's say the minimum number of data point, that let's say 4 or let's say 3. Okay, so if the data point that less than 3, then the DB scan will consider as a noise, as a outlier. Okay, so this is the hyperparameter. So user that can define this number of this minimum number of data point. Let's say 10 or 50 or 60 or 70. So minimum number of data point that should we consider the this 70 or 60 or 50. These are the hyperparameter. So how many number of data point we should consider to make a cluster? So that is the that we call as a mean point. So that we will see. Yes, outlier are considered as noise. Exactly. This outlier that are considered as a noise. Okay. Or you can define in the sense that if suppose minimum number of data points are in the bunch or in the group, okay, minimum number. Okay, minimum number, let's say we defined the 3, this mean point. If less than 3, then this that will be the outlier, that will be the noise. Okay, that we will see in more detail. So now the next point is, that is the mean point and epsilon. So let me define this mean point and epsilon. Okay, so that will be the answer of your question. How do we can define the noise? Okay, so now mean point. So the mean point and epsilon, these are two hyperparameter. These are two hyperparameter, means these are not fixed. Okay, so you can ask one more question here, means that is a density based algorithm. This is a density based clustering. So how do we measure the density around a point? Now question is, how do we measure the density, because it's a density based clustering algorithm. So how do we measure the density around a point? Okay, so the point is, we have to define the area. We have to define the area around the given point. We have to define the area that around a given point. Okay, and second, how many number of points around in that area. Clear? So I will consider a circle or a sphere, because this is the best to define the area. So let's say circle of radius 1 unit. Okay, so I will say the number of point, let's say this number of point is, let's say 10. Okay, if number of points greater than equal to 10, then we will call as a dense region. If number of point less than 10, then we will call as a sparse region. Okay, means sparse region means that we will not consider these 10 data point in a cluster. Okay, this 10 data point you can call as a means less than 10. Let's say less than 10 means 9. So you can call them as a outlier. You can call them as a noise. Okay. See this area and this number of point that we can increase or decrease as per our uh, database data set. Okay, this is a hyperparameter. So now the definition of this mean point is means it is a minimum number of point that is required to form a cluster. Okay, so it is a minimum number of point. So just give me a just wait. It's urgent call is coming. Wait. Okay. So mean point is uh, means minimum number of point means minimum number of point that is required to make a dense region. Okay, means that we have to consider as a cluster. Clear? That is a mean point. And epsilon, this epsilon that is a kind of again that is a hyperparameter, means how big my neighborhood. Okay, this is the epsilon. This one is the epsilon. That is the area. Okay, so how big our neighborhood is, that is the epsilon. So number of point and epsilon. So now question is, if we increase or decrease the data, how does it affect on to the output? Okay, that we will see. Yes, correct. So I will show you one animation. Okay, maybe in the last of this session. So I will show you one animation. So after seeing this animation of this DB scan, that you will understand if we increase or decrease the data, then how the DB scan able to make a better cluster or it's a bad cluster. So that we will see in the animation. Okay, so now epsilon that is a radius of neighborhood. This one is a radius of neighborhood. Okay, radius of neighborhood around a given point. Around a given point. Clear? So up to so far, if you have any doubt related to this mean point and epsilon, mean point means how many minimum number of point uh, uh, this required to just make a dense region, and epsilon that is how big my neighborhood is, that is the epsilon. Okay, so let's say that is the radius of this 1 unit, or we can consider the radius of 2 unit or 3 unit. Okay, so that is the area. Okay, so now after this mean point and epsilon, so there are three types of data point. There are three types of data point. First, we understand this some of the terminology, that is uh, this mean point, epsilon. Okay, the data point, types of data point. Okay, so after understanding of all this concept, then we will switch to the main core of this DB scan. So now three types of data point, that is the first one is the core point, second is the border point, and third one is the noise point. Now question is, what type of problem can be solved by using this DB scan? Okay, so this is the clustering. This is a clustering based algorithm. So that is customer segmentation. That yesterday that we have seen one application of customer segmentation. Okay, so at the last that we will see the application of this TB scan. So there are 3 or 4 applications that we will discuss at the last of this session. The application, the advantage and disadvantage, and the comparison of this TB scan with K-means. Correct. So now the first one is core point. Okay. So first, let me just explain this core point by a definition. Then this definition that we will understand by an example later. Okay, so the definition is this core point. That core point, a point is said to be a core point if it has a minimum number of other points. If it has minimum number of other point. Okay, this minimum number of other point means that is specified by the mean point and epsilon. So let's say prior that we defined this mean point is equal to 4, okay, and epsilon is equal to 1 unit. Epsilon is equal to 1 unit. So this 1 unit, that means that may be 1 centimeter, okay, 2 centimeter or 3 centimeter, okay, clear, or 1 millimeter, clear, and mean point that is 4. So now you tell me this one is my data set, data point. Okay, so now this one is a data point. So how would I identify that whether this data point is core point or not? The question is how would I identify that this data point is my core point? So around this point that we will draw a circle of 1 unit. That we will draw this circle of 1 unit. Okay, and in this one only that is 3 points are there. So this will not a core point. Okay, so there are only 3 points inside this circle. So now this number is less than the mean point. Okay, so this point that will not be called as a core point. Let's say this one is another data set, clear, and this one is a data point. Now again just you make a circle, this one. Okay, now this will be our core point. Clear. So means if the this inside this circle, if the number of this data points are more than this mean point, then this data point that will be called as a core point. So can you call it this point as a core point? Again just you make a one circle, okay, and just count the number of data point. If it is greater than mean point, then it's a core point. If it is less than the mean point, then it will be a it will not be a core point. Clear? So core point, that is very straightforward. That is just make a circle, okay, just make a circle of your dry circle of 1 unit and just count the number of data point. If it is more than the mean point, then that will be our core point. Okay, and if it is less than the mean point, then it will not be a core point. It's very simple, straightforward. The now next one is the border point. Now next one is the border point. So border point, that is this point, border point is defined by this two condition. First condition is it should not be a core point. It should not be core point. Yes. So there will be more than one core point. Yes. Amkar sir? Yes. Absolutely clear. There will be more than one core point. Yes. The, this is the only constraint on the core point. Constraint is just count the number of data point. If it is more than the mean point, that will be core point. If it is less than the mean point, then it will not be a core point. That is only the constraint, that the data point should satisfy the mean point. Okay. So now come to this border point. Border point, the first condition that has to be satisfied, that it should not be a core point. And the second one means should not be a core point means this let's say this one is a data point. Okay, let me explain this second constraint also. So the neighbor of core point means a border point is within the epsilon distance. Okay, this border point is within the epsilon distance of one or more core point. One or more core point. Okay, so let's say for example this one is our data point. Okay, so now I want to identify this one is a border point or not. And mean point, that already that we defined, so mean point is equal to 3 and epsilon is equal to 1. Okay, so now just make a circle. This one is a circle. Okay, so this point is fulfilling the the condition of this core point. Okay, because core point, that is only, sorry, not core point, let's say this mean point is 3. Okay, so now core point, correct. But border point, let's say this one is one more data point. Okay, this one. So now just you make a one more circle. Okay, and in this circle epsilon distance, this one is epsilon distance. Okay, so within this epsilon distance there should be one or more core point. If included in this circle, then this will be a border point. Let me repeat one more time. So let's say this one is my data point. Okay, and I want to identify this one is a border point or not. So this within this epsilon distance, this is a circle, this within this epsilon distance, that is the radius of this circle. So within this epsilon distance, so there should be a one or more than core point. If the core points are not lying in this circle, then this point, that will not be called as a border point. Just wait. Yes. Okay. Sorry, actually, one urgent call that has come. So now question is, so there will, yes, okay. Uh, Yes. So is there any doubt related to the border point and core point? Question is, could you kindly highlight the difference between the center and the core point? Okay. Center means that I have not defined any point as a center point. So there are only three types of point. One is the core point. Okay, core point means uh, it is related with the this mean point. If let's say one data point is one data point is there. Okay, we have to make a circle of 1 unit, or maybe that is 2 unit. That is as per this value, that is a hyperparameter. Okay, and just count the number of data point. Okay, and if it is greater than the mean point, then that will be core point. Okay, that I have not called as a center point. Clear? So just make a circle and just count the number of data point. If it is more than the this mean point, that will be our core point. Okay, just check with the another data point. Again, just you make a circle, count the number of data point greater than this one. Just this will be our core point. Just another one more data point, again just make a circle. Okay, clear? Okay, so now the third point is, that is a density point. Third point is density point. So density point means is a data point which can neither as core point nor a border point. Means it does means this noise point means it does not satisfy any of the condition of core point and border point. If the point does not satisfy the condition of core point and border point, that we will call as a noise point. Sorry, density point. No, not density. That is a noise point. If the point does not satisfy the condition of border point and core point, that we will call as a noise point. This one, noise point. Okay, border point that has the two condition. First condition, it should not be a core point, and just make a circle. Inside the circle, at least one or more than one core point that should lie inside the circle. Then only we will call as a border point. Okay, so I hope everything is clear to all of you. So now the next is a one more term that we will call as a, that is a directly density reachable. Okay, so there is a one more point, that is density connected point. Density connected point. So, but before this density connected point, so let us understand this directly density reachable. Okay, so directly density reachable. So when we can call as a 2 point is directly density reachable. Okay, and when we can call as a 2 point is a density connected point. Okay, so a point P is directly density reachable from a point Q. Okay, so we have given the value of this epsilon and mean point. If that is the first point is P is in epsilon neighborhood of Q, P is in epsilon neighborhood of Q, and second one, both P and Q are core point. Both P and Q that are core points. Let's say there are 2 points, that is P and Q. Is P is directly density reachable to Q? Okay, so here that is, let's say epsilon is 1, so just this one is epsilon, that is 1. Okay, and this one is a P point. Okay, and this one is Q point. So if P is in the epsilon neighborhood of Q and both P and Q are core point, then only we can call as a directly density reachable. Directly density reachable. Clear? The condition is both P and Q are core point. That must be the core point. And P is in the epsilon neighborhood of Q. But here, this P and Q that are, this Q that is not in the epsilon neighborhood of this P. This Q is not in the epsilon neighborhood of P. Okay, I have written here something different. P is in the epsilon neighborhood of Q. Okay, let it be. Okay, so here this Q is not in the epsilon neighborhood of P, then this P and Q that are not directly density reachable. Okay, so the last point is just to understand the core of this DB scan, that is a density connected point. Okay, so then that we will see the core of this DB scan clustering algorithm. So now density connected point, directly density reachable. Is there any doubt related in this directly density reachable? Directly density reachable means it's very simple. If P is a one data point, Q is another data point. So can we say that P is a directly density reachable of this point Q? So if P is in epsilon neighborhood, or here that we can understand this Q point is not in the epsilon neighborhood of P. Okay, although P and Q both are the core point, but the first condition that is not satisfied, this Q is not in the epsilon neighborhood of P, so this P and Q that are not directly density reachable. And the next one is, that is a density connected point. Density connected point. So this one is the most important, density connected points. So P, the one more, that is Q, R, S, T. So these are the 5, let's say, data point. Okay. So now this P, let's say P and Q. So in between this P and Q, there are, let's say, 3 more point A, B, C. So a point P is directly connected to Q. So that we have given some epsilon and this mean point. So if there is a chain of point P, A, B, C, Q, R, S, T, okay, and let's say this, let's say for example, P1, P2, P3, and let's say this one is Pn. There is a chain of data point. There is a chain of data point, and here P1 is equal to P and Pn is equal to Q. Okay, so these are the density connected point P and Q that Pi plus 1, okay, is density connected. If Pi plus 1 is directly density reachable from this Pi, from this Pi. then only this chain of this data point are density connected points. Let me take one example. So this P and A, P and A, P and A. First you check the directly density reachable. Yes, these 2 points are directly density reachable. A and B, yes, these 2 points are directly density reachable. B and C directly density reachable. C and Q directly density reachable. Then P and Q, that will be density connected point. Density connected point. P and Q, that will be density connected point. Hello. Okay, fine. So for density connected point, just we have to check this directly density reachable. We have to check directly density reachable. If the 2 points are not directly density reachable, then we will not call as a density connected point. Okay, so now this, I hope this everything that is clear to all of you. Let me just repeat one more time that then after that we will see the DB scan algorithm. So that is a mean point and epsilon. Okay, mean point, that is a how many number of data points are required to make a one cluster, and epsilon, that is how big of my neighborhood is, that is epsilon. Now the three data points, that is first one is a core point. How we can identify the core point, border point, and noise point. So if let's say data point is there, and just make a one circle, draw a one circle, and just count the number of data point. If it is more than the mean point, then that will be the core point. Otherwise, it will not be a core point. Border point, that the border point, that should not be a core point, and the epsilon distance of one or more this core point. Okay, and if the data point that has not satisfied the condition of border point and core point, that we will call as a noise point. Then the next that we have discussed this directly density reachable. So directly density reachable. So both the point that must be the core point, that is of one condition, and the second condition is if the point, this let's say Q, okay, is not in the epsilon neighborhood of this P, then that is not directly density reachable. So if the 2 point, let's say this one is a another Q dash, so P and Q dash are directly density reachable. Correct. And this density connected point, so there are let's say chain of point, data point, chain of data point, then P1 to this Pn, are they density connected point? So we have to check in between all the point. If any one of the 2 points are not directly density reachable, then this P1 and P2 are not density connected point, are not density connected point. Okay, so now let's discuss the DB scan algorithm. Now this DB scan algorithm, now uh, it is easy to understand after just understanding of all the this basic concept of mean point, core point, border point, noise point, epsilon, the density reachable, directly density connected point, all these things. So now in this one, that is the first step is, so before that you have to give the prior information of this mean point and epsilon. Okay, then after that, the first step is identify all the points as either core point, border point, or noise point. So now first one is identify all the point as core point, border point, and noise point. Okay, so first we will ask to each the data point, are you core point? If not, are you border point? If not, that will be the noise point. So first we will ask to each and every data point, okay, are you core point or not? Are you border point or not? If core point and border point they are not satisfied the condition, that will be our noise point. That is the first step. Okay. Now step two, for all the unclustered core point, that we will run a loop. Okay. So that we will run a loop. So that I will show one animation. I will show one animation. Just you first understand the this two or three steps of this algorithm. So now the second step is just we have to run a loop, and that just first you make a one cluster, okay, and add all the point that are unclustered and directly connected to the this current point into this cluster. That is the second step. Now the third step, for each unclustered this border point, assign the point to the cluster of nearest core point. Okay, and the last one is leave all the noise point as it is. Leave all the noise point as it is. So let me show you one animation. Okay, so now you see this one. Uh, yes. So there is a one example of this, let's say smiley face. Okay, and epsilon and mean point, you can just change the value from here, epsilon and this mean point, and just you check here this. Let now you just clear. So just based on the core point, based on the border point, based on the directly means that is density connected point. Okay, so now this will be our DB scan algorithm. Now you see this one. See this one. This. Okay. So this one is a cluster, core cluster. Then restart again. Let's say uh, this one. So again, just you go. Okay. So now you see this will be our data. This will these data points are just the noise point. Okay. These data points are noise point. These are also the noise point. Clear? So if you just increase the value of mean point and this epsilon, so there will be a different cluster. There will be a different cluster. Now see, this all the data points are DBs can call them as a noise point. Clear? So now in this one, this one packed, not packed, this pimple, this one. So again, just now I increase this epsilon value, this one epsilon value. Now can you see here? And this mean point is, let's say this one, let's say 8, 6. Now go. Now the size of circle is just bigger than the previous this epsilon value. Okay. Now can you see this animation and just can you compare the this epsilon and mean point with the previous value? Okay. So now tell me if you have any doubt related to this more epsilon means more epsilon means epsilon value if it is more means bigger value, the circle that is means circle that will be big. Okay. More epsilon, more noise. Yes, we are capturing more noise. Means that these are not the noisy data. These are not the noisy data. Okay, these are kind of not as an outlier, but DB scan that consider these data point as an outlier. Okay, see now this one and this data point, this one. It's not as an outlier. Okay, so this data point he can consider this data point in this cluster, but as per this epsilon and mean point, this DBs can this call them as a outlier. But you are correct. So more epsilon means we are capturing the more data set. Fine. So let's come back to our yes. So now the limitation, okay, and advantage. So now the advantage of this DB scan, first one, no need to specify the cluster number of cluster as we have to specify the number of cluster prior in K means here no need to specify how many number of cluster that we want, okay, initially. So that is the first, that is a kind of advantage in DB scan. So second is that we can find the arbitrary shaped cluster. Okay. So arbitrary shaped cluster means, let's say this one. K means that will make a one cluster like this one. It will make a one cluster like this one because it's a centroid based algorithm. But this DB scan, that we can find the arbitrary any shape of the cluster. Okay. And the third one is that is only two hyperparameter need to tune. It is one is the epsilon and another one is the mean point. Now next one is a disadvantage. Disadvantage is that is very sensitive to hyperparameter. This one is very sensitive, very big disadvantage is very sensitive to hyperparameter. Means if you change the value of epsilon and mean point, the entire different cluster that that will come out. Okay, if you change the value of this epsilon and mean point. So let's say uh, at very first you put the value of epsilon 1 and mean point is 4. Okay, let's say this one is a cluster, this one is cluster. If in the second time if you change the epsilon value on the same data set, if you change the epsilon value that is 1.2 and mean point that is let's say 5, then maybe this one is a data set, sorry, this one is a cluster. So entire different data, entire different cluster that you will get if you change the this epsilon and mean point. So it's very sensitive to hyperparameter. Okay, and one more disadvantage is means it's very difficult to get the cluster if we have the uh, varying density of data point. If we varying the density of data point, let's say this one is highly densed data point and this one is low density. Okay, so the point is this DB scan actually consider one common value of this epsilon and mean point. Okay, actually DB scan that should consider the different size of epsilon for this one and different means another value of epsilon for this cluster, because here the density is less and here that is density is more. So the DB scan that should consider the different size of epsilon here in different size of epsilon here. But the point is there is a common value of epsilon and mean point for whole data set. So there is a difficult with varying density cluster. Now the next one is that is application where we use this DB scan. So the first one is anomaly detection. Means this DB scan that effective the noise or this outlier core cluster. Okay, so which make this algorithm that use task. So that is first one is a anomaly detection. Second application is image processing, means in object recognition and segmentation. Image recognition and image segmentation. So where the goal is to group the pics and make a meaningful structure. Now, third one is a customer segmentation. So this customer segmentation that as we discussed yesterday, let's say in Myntra, you big sale. So try to send the message to all the people to only one group of people who is a lot growth in a year. So that is a customer segmentation. Customer, okay, okay, and one more application is spatial data analysis. Okay, so we will use this DB scan. Yes, inform. So this one that we use in application like identify the region of similar land, the similar land that use in the satellite image. So that is GIS, geographical information system. So these are few applications of DB scan. Okay, and that we had discussed the basic this intuition of this clustering algorithm. So now, any doubt related to the topic that we had discussed so far, now you please write on the chat box. Yes, any question from the participant side? Okay, so if no question, no is there, so we can just wind up the session. First question is how do we discuss question